Next Tuesday is our Chapter 1 test. So there'll be no quiz on Monday because that's not fair to give you guys, or we could, but you know we're nice people. So instead of giving you a quiz on Monday and then giving you a chapter test on Tuesday, there'll be no quiz on Monday, but Tuesday will be the chapter test.
Oh my gosh, thank you so much.
You're so welcome.
I don't want to take 2 tests.
Right, absolutely, absolutely. Yep. So yesterday, you guys just had a couple problems. What was it, that 84 through 87, 88, and 90?
Yeah.
You guys, right, yeah. I keep thinking today is Thursday and not Wednesday. It does. It's been a crazy week. Again. All right. So do you guys got any questions on yesterday's problems? 87? All right.
Landon.
All right. So problem 87, they want you to write and solve an equation for the following problem. So you have a cable that's 84 meters long and it's cut into 2 pieces. So being cheesy here, here's our cable, right? And the whole entire thing, I can never draw these little brackets. I guess I need to move that down. You got a cable and the whole entire thing is 84 meters, right? And then it says that it's cut into 2 pieces. So it doesn't matter where you cut it. So let's say you cut it right there. And one piece is 18 meters longer than the other. So what's the one piece gonna be? Do you know how big it is?
No.
No. So if we don't know what it is, what are we gonna call it? X, right? And then what does it say the other piece is?
Something. It's X plus something something.
Yeah, 18 meters longer. So if it's 18 meters longer, it's whatever that little piece was plus 18, right? Well, they're not equal to each other, right? But how far is the whole entire piece? 84. So let's just say for poops and giggles, if this was 4, this piece would be, if from here to here was 4, how far would the rest of it be? 80, right? And how do you get 84? You took this piece and you did, and then you added that piece, right? So you added those 2 pieces to get 84. So even though there's variables, what are you gonna do? Add those 2 pieces, right? So that X plus this other piece, I'm just gonna throw it in parentheses just to show the 2 pieces. And when we add those 2 together, what's it equal? 84. So I need to solve it for, what do I want to get all by itself? X, right? Because we always want our X's by themselves. So how many X's do I have? X plus X is 2X, right? Plus 18 equals 84. What am I going to do now? Subtract 18 from both sides. So I'm going to get 2X equals 66. Yep. And then what am I going to do? Yep. And X is going to equal 33, right? So when I go back up to my problem, how far is it from here to here? 33, because that's my X, right? And then how big is the other little piece going to be? 51, right? Because you just put in that 33 for X, so 33 plus 18 gives you 51. Meters. Throw some old M's in there for some meters. Not too bad? All right. You guys get any other ones?
I don't feel thirsty.
You what?
I feel thirsty.
Don't tell me you feel dizzy.
I'm thirsty.
Oh, I don't want, no. I'm like, if you're feeling dizzy, I gotta send you down to the cares room, I think. I don't know.
What's a care? We don't care.
They care. We care. We care. All right. So you guys good with the rest of them?
Yeah.
All right. So today, we're gonna finish up with our 1, 2, 2, which was that function investigation. Yeah.
We're gonna investigate the function.
Yep. Same thing we did yesterday. Literally the same thing we did yesterday. Yep. Same thing we did yesterday.
Okay, yesterday, part 2.
Yeah. All right. So remember yesterday we looked at a function and you guys had to make that little table and that little graph. Remember that? Yeah. So without going through all of it, like how we sat there and, you know, made our page like very sloppy and nasty right there, right? I mean, that was kind of all crazy. So we're ultimately going to try and do this a little bit without doing all of that. So if I give you guys getting dizzy yet?
No, I can't tell you that.
I forgot. So f of x is telling you that you got some little function going on, right? That's your output or your y. If I gave you 1 over x plus 25, predict, make a guess using that judgment from what we learned yesterday. See if you can like just draw like what you think the graph would look like. It doesn't have to be perfect, you're right, but I want you to see if you can, from what we did yesterday, give me a nice little X and Y. And on your paper, somewhere on your notes, right, predict the graph. Something like that. You guys got your prediction down yet? Yeah. And then after you guys make a little graph of what you think it's going to look like, jump on your fancy dancy school Chromebook and go to Desmos.com. Yep. Yeah. Desmos.com. Usually that graphing one's that very first one.
The scientific term.
See, I don't know if this, it does, okay. And you don't have to write f of x. Instead, we're gonna write y equals, right? What are you gonna write? 1 over x plus 25. Is that what yours look like?
If I can figure out how to do that.
Wait, how come we don't do that? How come we don't?
It does, but it doesn't upset your mouth.
It does it off my mom?
How
Oh, I thought
do
you
you get the light?
The division, it's the little
It's this slash.
slash,
Yeah.
backslash.
Okay.
Yep. Yeah. So is this what your guys' graphs look like?
Then there's the
No.
asymptote.
Yeah, because what do we need to do? We need to zoom out, right? Because remember the one we did yesterday, we had an asymptote at 7.
Mhm.
What do you think you get an asymptote at now?
25, negative 25.
Negative 25, right? Asymptote, yep. So we technically actually have 2 asymptotes. We're going to go 5, 10, 15, 20, 25. Right? So when it comes to drawing our asymptotes, what do we do on our graph?
You put like the whole thing.
Yeah, put that dotted line, right?
Show where.
Yeah. So when it comes to our asymptotes, they're going to ask you like where that asymptote is. And we can have vertical asymptotes, we can have horizontal asymptotes, and we can have slant asymptotes. So on this one, it's going up and down. So is this a vertical, a horizontal, or a slant? It's a vertical one, right? So we have to name all of these by their equation. So if you have a vertical line going up and down, it's going through where x is negative 25. Right? And no matter where you are, oops, on this asymptote, x is always going to be negative 25, right? So that's actually the line, x equals negative 25.
So we didn't have to make the table?
No.
No. Did you make a table?
No,
Oh,
I just
yeah.
thought we did that yesterday.
Well, right, because we were starting the investigation. Right now we're smart and we know, right?
So how would we know if we didn't have the decimals?
Because we have the 1 over, we have, it's called a rational function, and we're going to get to the name. So because you have the fraction where your variable is in the denominator,
Mhm.
right? So it's going to give you that funny shape we just got where it's going to have the asymptotes to it. And then what can the denominator never be? What value can the denominator ever equal? What can you never divide by? 0, right? So your denominator can never be 0. So when it comes to your asymptote is that number that it can't be. So it can't be the number that makes it 0. And what value would make it 0?
So
Negative
We
25.
can just look at it and be like, negative 25.
Yep.
And that's what it is. Okay.
Yep, yep. And then we technically have one other asymptote on here too. If we go back to our graph, do you think there's anything else where it looks like it's getting really, really close to, but it's never touching? Well, that's, oops, yeah, I go the wrong other way. Well, that one, you know, decimals is sometimes just as good as the zoom is. Is it ever crossing over the axes?
So it's never gonna go into the X. Well, no, it's close.
So we also have an asymptote, whoops, going through here, right on our axes. So I lucked out, I have a different color, you guys don't. Is that one horizontal or vertical? Horizontal. So we name horizontals by what y value they went through. And so this one would be y equals 0. And now that you got your cute little asymptotes, you can kind of just, and it doesn't have to be perfect, right? It's gonna look something like this, right? And then the other one was down here-ish. But make sure we got those arrows on there, because that arrow is saying that it's getting closer and 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 closer to that asymptote, but it's just never gonna touch it,
So
right?
is that like a question? Like on the test, like. So
It could be like what's the asymptotes or graph, right? They could ask you to graph it. So if you were asked to graph it, like the biggest thing is showing me that negative 25, right? Or the asymptotes, of course, but right. So you got to put some numbers on your graph so I know. So were you pretty close to your prediction when it came to graphing these?
I mean, I didn't know how to do it, but I don't know how to do it.
All right. Let's see what's on the homework for today. You guys, yeah, no. You get to solve some equations for some variables. So for example, you have something like y equals mx plus b. What's that called? Anybody remember?
Slope.
Slope-intercept form. So they might say, you know, good job, good job. I can't spell today. That's supposed to say solve. Solve for, let's say m, right? So when they tell you to solve for m, that you're just rearranging everything until you get m by itself. So we want to get this guy all alone. So what do you think we're going to get rid of first from that side?
The B.
Yep, so what are we going to do?
Subtract B.
Subtract b from both sides. You're just going to get y minus b, right? They're two different variables. You can't combine them. And that's going to equal mx, right?
Divided by S.
Divide by m or x.
X is 1.
Yeah, because you want m by itself, right? So you want to divide by x. Divide by x. So y minus b over x equals m.
But that's not like the answer.
It is.
Oh,
It's,
even like if there were numbers.
nope, no numbers.
See, that's confusing.
Yep, you're just rearranging the letters. Yeah, just rearranging the letters. Yep. What else you got? Create a table. And they give you the equation, create a table, make a graph. You guys are good at that. Ooh, careful.
Yeah, at least you got the case. At least you got the case.
It's okay. You know, gravity still works and accidents happen.
I ain't know gravity works.
Yes. All right. It's still working, right? It hasn't, we're not floating yet. I'm sure. Yep. Hold on, guys. Suppose you got two lines and you want to find the intersection. So they have you going through the algebra to solve it for algebra. Oops, you get some words to come up with your own little equation. Think of ratios. Ratios might be a good one on that one. And then looking at another graph and making a sketch. Sketching. And then matching up some equations with words. So like the Pythagorean theorem, quadratic formula, laws of sines, and laws of cosines. All right.